In the previous video, we handled the collision between the cat and the furniture, and we also add some visual effects when the cat breaks something in the flat to make the game more snackable. So we're starting to have something with a nice look, but it's still not enough for a hyper-casual game. You really have to impress the player. It's really important to display scores, particle effects, visual effects, in order to really blow the player away, and that's what we're going to do in this video. If you remember, we created a hittable object script that has a number of points an object gives. I'll just select the big objects here, doing this quickly. I just need to have some different objects. I'll put 200 points on these few big items, for example, and I'll take some medium items here. I put 100 points on them. And then let's say the computer is a bonus item, put 500, changing the value to add a bit of variation. What we'll do now is increase the score when we collide with an object. And if I remember correctly, we had done that in our template. We had created the obstacle script for our template, and we had the text. Let's check what we did. We made a game object.find to get the score, so the text of the score. Then we had a punch scale to make a visual effect. After that, we calculated the new score. Well, that looks good. We'll keep this code almost as it is. Let's see. Yeah, we'll do almost the same thing. I'll copy that, but instead of doing a gameObject.find, we'll fill in the variable directly. So I'll copy the gameObject text, I'll go into the cat header, and in the cat header, I'll create a variable that will be the text score. Except that, as I said, we'll fill in the variable directly rather than go look for it manually. So where is our score? There. We have score text here. I take the cat player and drag score text onto the text score, like this. So the variable is already filled in. Go back. Here we have our text. At the time of the collision, we can do I-twin punch scale like we did. So when the collision occurs, I'll do I-twin punch scale on the text score. We'll do something more discrete. I write a .25f. It will be a bit more discrete than what we did. And since we'll have a lot of changes to the score, I mean really a lot, we'll do it over a shorter period of time, like 0.5f, in order to have a very fast visual effect, even 0.3. Then we'll do the same thing, we'll calculate the new score. New score is equal to int.parse of text score dot get component textmeshpro.ui.text. Here we'll retrieve the score already present. TextMeshPro.ui is not recognized. We need to do an import of tmpro like we did here. Add the imports, and there the error is gone. And instead of adding 1 to our score, this time we're going to add, we recovered the rigid body here. I'll do the same thing. I'll recover the hittable object. I'll call it HO. And I'll say that it's equal to hit.gameObject.gameComponent, and I won't recover the rigid body, but I recover the hittable object, which is the script that we created ourselves and which contains points. So instead of adding 1 to our score, I'll access the hittable object script of the hit object dot point to get the number of points associated with the hit object. So I'll increment my score by the right number of points, and then I'll modify the text value. I'll do text get component, then I modify it to associate it the new score. Okay, that should work. We did this a bit faster because we took an existing script. I told you the game template will help you save time. Okay, the score is at the top left of the screen. There, I have my score increasing and we do have the visual effects. Yeah, it works well, pretty good. I'll try to break the laptop if I have time. Yeah, no, almost. Wow, you can see the score is increasing with a nice look. We could stop here and it will be enough, but I told you it's good to really blow the player away. So now I show you another nice little visual effect. Okay, what we're gonna do, let me think, just trying to figure out the best way to do it. I do game object, 3D text, which will allow me to create a 3D text that you can see here. This text has properties. I'll align it to the center and I'll align it to the middle center. So we've got this 3D text roughly there. We can't see it very well, so I'll reduce its size like this. Yep, better this way. I lift it to put it above the cat's head, and I'll put, for example, 100, just to see how it looks. So each time the cat will touch a piece of furniture, this will display the score obtained by having broken such or such piece of furniture. Oh, that's why I put a number to be able to see the size of the score here. And if I play, we can check it in the game. It's in 3D since it's a 3D text. Now, the text is not yet attached to the cat, but we can see that the size of the text is a bit too small. So we'll put this text in the cat in order to attach it to the cat, and I'll increase the character size here. I'll put 4. I'll put a bold font style, and instead of Arial I'll use Varela to keep the same font we already use. And then I reduce the text size. Now, look what I'm doing. The text is actually blurry. I'll increase the character size, I'll put 16, and I'll reduce the text. By doing that, we get a better resolution. If I increase the character size but decrease the object size, we increase the resolution a bit and have a better looking text. We'll test it again to check. I'll launch the game, click on play, and there we see that the text is hanging on the character. But we still got a problem. Like if I'm like this, the text can't be seen, and if I'm like this, it's reversed. So the text should always be oriented toward the player. And first I'll even add a plus before the number 100 here. So yeah, I was saying the text should always be facing the player. I'll show you how to do that. I'll first center the text in relation to the cat. That seems good. I'll change this to score text. And I'll show you how to do it. This principle of having something always facing the camera is called the billboard. So I'll create a script, right click, create C# script, I'll call it billboard. And this was a principle used in old games. Maybe you know the game Doom. Well, all the Doom-like games were not in 3D. They were in 2D, but the 2D objects were facing the camera, and it gave us the impression the game was in 3 dimensions. So the code is just transform.lookAt to say to the object to look somewhere. And in brackets, there is what the object should look. We'll say camera.current.transform. Camera.current is the current camera, the one of the current game, and .transform will allow us to recover the position of our camera. This way the text will always look at the camera, because we are in the update function. Okay, let's test this. I'll select the score, I'll add the billboard script to it, and I launch the game. Play all, and that's a fail. It didn't work. Let's see why. Always think of checking your console to see if you have an error. Here, something isn't found. It might be the camera. Well, I'm not going to investigate too much because it's not the purpose of this video. Instead, I'll do it another way. Public transform can. And I say, look at the camera. Well, maybe it's camera dot main instead of current. Yeah, no, well, anyway, I'll use directly a variable for now. So what I'm doing is creating a variable for the transform of the camera, and so I have to get the camera here. We'll test and launch the game. Well, we'll have another problem, but I expect this one. You see it works, no matter how you orientate the cat. The text is facing us, but backwards. So we're almost there. So this is because the blue arrow that represents the front of the text is here. And so we want it to face us. So if we want to make a correction without programming, what we can do is going to game object, create empty, and I'll create an empty object at the position of the text. I rotate it 180 degrees, and if I set a local, the blue arrow of the empty object is here. We still have the blue arrow of the text on the other side. I'll take the game object I created. I'll put it in the child of the cat. I'll call it score text holder, like the camera principle, if you remember. In it, I'll put the score text. I'll deactivate the billboard on this score text. I'll select the score text holder. I put the billboard script. I put the camera. Now, the billboard is applied to the score text holder, which will be facing us. Let's test. Okay, there we have our score, which appears on our head permanently and in the right direction. Okay, we're good. Now, we'll delete the text as it was just a model to be able to configure the whole thing, to configure its style and to point it at the camera and to do our tests. So, but we're now ready, so we don't need it anymore. Now, we're going to display this text as soon as we collide with an object to indicate to the player that he has won this amount of points. Then we'll hide the text again. We'll let it be displayed for a few seconds just to have one more visual effect. For this, we go back to our cat header. We'll create a public game object, and I'll call it textScore 3D, 3D being the 3D text above the cat's head. I'll go back to the cat object, and where it is, yeah, I'll drag the score text, not the order we just created, but really the score text. Actually, I just think I could directly do a text mesh. Yeah, because I don't want to bother with the conversion later, so we'll just do a text mesh. Yeah. So what I did was I created a text mesh, a variable of type text mesh. The text mesh being the variable that represents the 3D text type here that we used. Why did I do that? Well, I just don't want to bother with a text mesh get component later on. In fact, I think I'll just need to access the text here, so I'll do it like this. The moment I collide with an object, I'll tell it text score 3D.text is equal to the number of points we've earned, except that I want to display a little plus, so I'll write plus to display the plus symbol, and then I'll do a plus outside the quotes to do a concatenation, and I'll define the number of points. So it will say that the score is equal to plus, for example, 100, plus 200, plus 50. Okay, that's it. Then what we'll do is resetting the text, because we want it to be hidden after like a fraction of a second, for example. I'll create a public void reset text 3D function, which will just do text 3D is equal to nothing. So which causes the text 3D to be reset. And what we can do is invoke of this function here, comma 0.5f, which makes that function will be called after a bit of time. Like after 0.5 seconds, we'll call this function reset text, which will reset the text. So we'll test that, launch the game. We play, I jump on the table, and there I have the text that appears and disappears. Okay, there, we created a new visual effect. Oh, you still can improve it. You can use the iTwin.punch scale to animate the text that appears above the cat's head with a nice effect, but for now I'll stay like this. It's already not too bad like this. Yeah. Okay, we'll stop here for this video. So we've seen how to calculate the main score plus how to display the number of points you earn per impact each time you touch an object. Now the player has a very precise idea of what is happening to his score, although you can totally improve the visuals. As I said, a little punch scale on the score that appears on the character could be nice. Once again, feel free to work on your game and improve the base I show you here. I hope I give you something complete enough to build on it. See you in the next video to continue the creation of this game.